Okay, this paper is part of research done for the Open DNSSEC project. I wrote it together with Benno and Matthijs. I'll just get started because I have to fit it in 20 minutes. What do we have? We have DNSSEC, DNS, and I like that. I own my own data and I can change it to whatever I want and whenever I want. But that means every time you want to address me, you have to ask me how to do that. So I'm a good guy, have good intentions. I give you a TTL and essentially promise you that this data is usable for the next couple of hours. And then on top of that, we place DNSSEC to make everything better. Okay, for DNSSEC, of course, I need keys, and some way or another I lose trust in a certain key. Maybe over time, maybe there's some compromise of the key, and I want to switch key X to key Y. So let's just do that. I throw everything from key X out of my zone, the signatures, the DNS key, also the DS, and I'll put everything from key Y in and publish it. And I think I'm happy, but you suddenly stopped speaking to me. Now, why is that? That's of course because of the TTL. I gave you data and I promised it would be usable, but then perhaps you have some signatures from the old key in your cache, which should be still usable, or at least I promised it would be usable, but you have to refetch the DNS key. Of course, you get a new DNS key that doesn't match with the signature, and you'll just say it's bogus. So rather than switching keys, I have to actually roll keys, which is a process over time, and the timing and the order of events is quite important here. It's also a source of much confusion, but luckily it's documented. There are a couple of operational practices which describes how these rollovers should happen. I call these rollovers recipes because they just say, do this, do that, do that. For example, this is a ZSK pre-publication rollover, which is just do something, wait some time, do something more, wait some more time, etc., etc. So, that's great. Now I want to write some program that does these rollovers automatically. So I'll just implement the recipe. But wait, actually the recipe I have to use depends on the kind of key I'm trying to roll. So I have 3 recipes. Well, sure, I'll implement all 3 of them. But now I would like to sometimes also change the algorithm of my key. Can it do that? No, it can't, but I can come up with some recipes to do that. Great. Say, for example, we have a split key. We have a KSK and a ZSK, and I want to roll it to a CSK, or the other way around. Can I do that? Well, sure, I'll make something up. So, while we're at it, I also like to minimize the number of DS records at my parent, because maybe changing the DS is a difficult process. it takes a long time, so I'd like to publish the least number of DS records as possible at the same time. Sure, more recipes. If I can do this, I can also, of course, do the same for the DNS key. And, of course, why not for the signatures? I'm running out of slide here. But I'm not quite done. I can maybe, in some situations, I can minimize the number of DSs and the number of signatures at the same time. I think I need about 3 slides. And if you give me enough time, I think I can come up with some scenarios with some other things you might want to do. And when it really explodes is here in case of an emergency. If you want, if you are in the middle of a rollover and you suddenly decide, wait, I no longer trust my new key, or maybe this key was generated with leading zeros or whatever, and I want to get rid of it as soon as possible, and I don't want to wait till it's fully propagated. That means that in every step of every rollover, I should have a plan to go back or continue with a new key. And then I'll need many slides to do this. So what would a sane implementation do for automatic key rollovers? I think it would say, I'll just implement a KSK rollover and a ZSK rollover, and that's enough for everybody. Now, I might not be a sane person, or just there's some other reason that I'm not happy with this. So I figured, what would you do if following recipes is no longer good enough? I think I have to learn to cook. And that means for my program, I have to formalize the ingredients, and I have to introduce some intelligence about DNSSEC. So, for example, in this very high-level overview, I have some key A and B in some state, and I have some target state for A and B below, and I want those keys to get there. I hope to find some logic that, when applied to it, the states of A and B get closer to my target states. And if I keep applying it, eventually they will get there. Small comparison. This is the ZSK pre-publication rollover we saw earlier, and on the left you see the recipe, which steps 1 till 6, and which says just do this. This is my state machine, and then you've done a ZSK pre-publication rollover. On the right, the picture we saw before, we just have key A, B, and their target, and let's apply our general logic on it, and it will get there as well. A bit more different is a combined key rollover while changing the algorithm. And what you see here, I don't have to change the logic. It's just, it's the same we're talking about, still DNSSEC. While in the left example, the steps 1 to 6 we had earlier is now 1 to 10, and every step means something different. So we have a lot of different state machines for each recipe. Let's make it a little bit more interesting. Let's say we have two keys. We have KSK and a ZSK. We want to roll it to a combined key. Oh yeah, and we also want to change the algorithm on the way, minimize the number of DS records published at the parent, minimize the signatures, and oh yeah, we're in the middle of another rollover and we're breaking that up. If we know what DNSSEC is, we can do that. I don't think there's a recipe documented for this, or I'm not sure how it's called. But I want to be able to do this. So, how? The recipe approach I call rollover centric. You are somewhere in the recipe, and that's your state. That's your state machine. And what I want to do is I want to keep state per key, and I want to see how the world sees our key. And the world is, of course, all the validators in the world, and they're talking. They're seeing my zone through a cache. So I'll introduce a simple state machine for everything, which represents for a resource record how well it's known in the world. So we have the start state, which is hidden. It means no one has ever seen my resource record at this moment, or everybody's forgotten about it. Likewise, I have another certain state, which is omnipresent, that I know that everybody is able to use my record. Maybe it has it cached and with a non-expired TTL, or it will, when it will ask for the data at me directly, it will get this record. And then we have two uncertain states, starting with rumored. That's when we publish a record, but not long enough to know that everybody can use it. Maybe someone has still all data in its cache, but with a non-expired TTL. All we know is that if we wait long enough, something to do with TTLs, is that our record becomes omnipresent. And on the right side, we have unretentive. It has almost the same meaning, only we stop publishing the record, and we know if we wait long enough, then everybody will forget about this record. Another thing to note here is we can actually switch between the uncertain states, and that's quite important to achieve this this emergency rollover, or to ensure we always have the shortest path to get rid of a key. Also another important thing to note is this is for a resource record, the state, but the key of this resource record has a goal. And the goal is either hidden or omnipresent. That means the program will try to, when evaluating all the state, will try to get the state a bit closer to that goal. With a key, there are a couple of resource records associated. Of course, the DS record, it's the DNS key, and all the signatures in the zone. I also have a special state machine for the signature of the DNS key set. That gives us yet some other rollovers we can do. So a key has multiple of these state machines, and of course in my zone I have at any time multiple keys. And that gives me a whole bunch of state machines and a lot of expressing power. I can say for every key how well it's known to every validator in the world. The problem is not all these states are valid DNSSEC states. Means I cannot always build a chain of trust, so I need some intelligence. That's this. That's too much for the talk here, so I'll just put it back in the cloud for now, which you saw before. But the reason I'm showing this is because if you're reading the paper, this is, of course, the most important part of formalizing everything. What I do want to say about this is that the rules, these rules work on 3 levels. That's on the first level, there must be a DS in order to have something that validates in some state. A layer lower, we say, okay, if we have a DS, we also should have a DNS key in one of these states. And even lower, we say we should have signatures. By having this layered approach, we gain some robustness. So if something breaks in one of these layers for some reason, we find ourselves in an invalid state, we can, in a graceful manner, repair that. Well, of course, we're flexible. What I explained to you, just throw in a whole bunch of keys in whatever state with whatever goal, and it just it will go there eventually without ever losing the valid. The validators can always build a good chain of trust. So I guess that's what I wanted to tell you. Thank you.